Hello, everyone. My name is Cormac Hogan. I'm a Chief Technologist at VMware, and I am delighted to be asked back again to deliver this session on Kubernetes for vSphere administrators. Delivered a similar session to you last year, if memory serves. Okay, so we only have 30 minutes, so let's crack on. And I guess the first question that we might have is, why do you want to run Kubernetes in the first place? Well, it's all down to the applications, really. The nature of applications is changing, or is in the process of changing. And so Kubernetes has come to the fore as a way of managing the infrastructure behind those new applications. So what do we mean by that? Well, how do we mean by applications are changing? Let's take a look at that. I think if we went back a couple of years, most of us would be familiar with the application view on the left-hand side. So we might have a multi-tier application. It would be made up maybe of a number of virtual machines. These virtual machines would have their guest operating system installed on them, and then some large monolithic executable would be installed as part of the application. And this was great for us. I mean, we built so much automation and so on around this particular paradigm, everything from Power CLI to Python scripts, you name it. We could roll applications like this out very quickly on vSphere infrastructure. However, developers were facing a challenge with these large monolithic executables. So every time they needed to patch them or make a change to them or even debug them, they were faced with, thousands upon thousands of lines of code. Making a minor tweak in one part of the application meant they had to, validate everything end to end. It was taking a huge amount of time, wasn't very agile, and so on. So they needed a solution to that. And containers provided this solution. Containers were a way of taking this large monolithic application over thousands of lines of code and breaking it up into a distributed application that was made up of lots of smaller constituent parts. So containers allowed them to break large monolithic applications up into distributed applications, and that addressed part of the issue. But it led to a new issue: is how would you manage all of this distributed application that's spread across lots and lots of containers? How do you scale it? How do you manage it? How do you monitor it? All of that stuff that we've dealt with virtual machines and vSphere for the longest time. Now they're facing the same issues with containers. And that gave rise to Kubernetes. So Kubernetes, I suppose in its simplest form, is a container orchestrator that allows us to manage, monitor, scale in, scale out the new distributed applications. Now, that's not to say that virtual machines are going away. We will still see virtual machines in their current form for a very long time. The reason being that not every application lends itself to be refactored into this distributed format. Various reasons for that. One is cost, one is risk. Are you sure that the application will run in exactly the same way as it did before? So for all of these reasons, we'll still see virtual machines around, but we will also see a lot of new applications that are containerized and distributed as well. Now, when we talk about Kubernetes in this context, we're talking about that Kubernetes cluster, which runs as a set of nodes. These nodes are virtual machines running on top of vSphere infrastructure. So you now have a Kubernetes layer running on top of a vSphere layer, consuming the underlying infrastructure resources. So that's why it becomes important for vSphere administrators to have some appreciation of how Kubernetes works. And that's our plan in this presentation, is to talk about a couple of areas where vSphere administrators can begin to onboard with Kubernetes and start learning about Kubernetes while still having some mapping relationship to what's going on at the vSphere layer as well. Okay, so let's begin by talking about the Kubernetes building blocks. We'll give you an overview. We're not going to go into a deep dive of all things Kubernetes, but I think this Kubernetes building blocks is a good way of getting started, good way of getting you some context on how Kubernetes ties together and how, in fact, it relates to the underlying vSphere infrastructure when it's run as a set of virtual machines on top of vSphere. So we're going to start with the control plane. This is basically the management entity of Kubernetes. Now, it always comes as an odd number of nodes. And again, these nodes are virtual machines when we're talking about Kubernetes running on vSphere. It could be 1, 3, 5, or 7. In this case, we have 3 control plane nodes. And what runs in the control plane nodes are a number of components that allow for the management of Kubernetes. So the first is etcd. It's key value store, and it's essentially where the configuration information for the Kubernetes applications, let's call them the applications, are stored. Second thing is the interface and how you communicate to Kubernetes. This is provided by an API server. You usually use a command line interface, kubectl or kubectl, to communicate to the API server, to query what's going on, ask it to do things on your behalf, all of that good stuff. Then there's a scheduler. And again, the whole idea of Kubernetes, as I said, in its simplest form, it's a container orchestrator. So it's kind of deciding where to run the containers that you wish to. Containers are obviously your application. It decides where to run these containers. And we'll see the second part of a Kubernetes cluster in a moment, and that'll be where the containers are run. Last but not least, you might have heard the terminology around Kubernetes of it being an eventually consistent system, or eventually consistent system. So this is, it's sort of at odds at how we do things in vSphere. If we ask vSphere to do a task like create a virtual machine, it'll either succeed or it will fail. And if it fails, it'll tell you, I failed to do this. You'll have to fix whatever the problem is and then retry the operation. Kubernetes doesn't work like that. Kubernetes is eventually consistent insofar as you ask it to do something, and if it is unable to do that task at that point in time, it will continue to retry indefinitely to do that task for you, in the understanding that eventually whatever is required to make that application run will be available, will be addressed if there's an issue. So it's eventually consistent, and how it achieves this eventual consistency is through this concept of controllers. These controllers are always watching what's happening, watching the configuration, looking for change requests that are coming in, and then implementing those change requests. So the controllers are essentially that entity that takes the desired state that you've requested and making it into the actual state of the cluster. And as I said, it'll fail, but it will continuously retry and eventually become consistent, making the desired state the same as the actual state. Okay, so that's enough about the control plane. Those are the major components in there. Let's now have a look at the worker nodes. And again, these worker nodes are virtual machines, and there can be very many worker nodes. I'm just showing 4 here, but you could have single worker nodes, you could have node worker nodes, I guess, but you can have in the hundreds of worker nodes as well. So in each of these worker nodes, there's a kubelet, essentially the Kubernetes agent. It does a lot of Kubernetes-related tasks on that worker node, but it also provides a communication channel back to the control plane as well. We have a concept of a container runtime. This is the component that understands how to run containers on the operating system that's in the worker node. As I said, the scheduler figures out where to run the containers, and then it makes the requests of the worker to run that container, and the container runtime will take care of setting up the configuration that's required to run that container. Last but not least, you have this kube proxy, and that's essentially to do with network management. You'll see later on when we run an application, and then there might be an outside request to access the application. Well, the outside request may come in on any of the worker nodes, but the endpoint could be on a specific worker node. And so what kube proxy does is it just routes or forwards, I suppose is a better description, the request to the appropriate endpoint on whatever worker the endpoint is available on. So there you go. There's the control plane section. There's the worker node section. So now let's have a look at the personas that might be using this Kubernetes cluster. We have our DevOps persona. So this is the person building out the applications, building out the components that make up the applications. They're going to communicate to the API server, and the communication is done through kubectl or kubectl, essentially. And so this DevOps persona creates YAML scripts, yet another markup language, YAML, defining the application layout, sends it off to the API server. The API server does all of the good stuff that is required about creating the objects for building out that application in conjunction with the controllers, in conjunction with the kubelet, and so on. So there's our sample application. I've just put a few of the major objects that you might find in Kubernetes as part of that application. So the service would be the front end that allows well, we'll see shortly. It will allow both internal parts of the application to communicate to each other, but will also allow the outside world to communicate with the application. We'll dig into services in just a bit. The pods are essentially your container management construct. And so a pod would contain one or more containers. And then last but not least, if you had a desire to do persistent storage, in other words, you want to preserve data within the application, you might be building out persistent volumes. Those are the PVs that we see there. Great, so the application has been stood up, and now we have some application users outside, and so they come in. They can come in on any of those worker nodes. They would connect to a what's known as a load balancer front-end service, which we'll talk about in just a second. And the kubeproxy will be responsible for routing to that appropriate endpoint. Okay, so again, very simplified overview of how it all ties together. As I said, there's a lot more to Kubernetes than what I'm showing you here, but this is a very just simplified overview to get the major building blocks in your head, and then we can take it from there. So we mentioned pods. Pods, essentially the unit of compute. They run one or more containers. There you go. And then we come on to persistent volumes. Now, this is an area that the vSphere administrator is going to definitely get involved in, because when we create persistent volumes on Kubernetes, that is running as a set of virtual machines on top of vSphere, the persistence comes from your vSphere data stores. So whether it's VMFS, NFS, vVols, vSAN, that persistence comes from those data stores. So there's definitely going to be interaction there between the Kubernetes administrator and the vSphere administrator to figure out the storage side of things. We're going to delve into that in a lot more detail. Now, the final point to make here, and we'll get back to it later, is that VMware has created its own driver, the vSphere CSI, short for Container Storage Interface. This is a driver that sits in Kubernetes that allows Kubernetes to build persistent volumes on vSphere storage, but we're going to get into that in more detail later on. But definitely an area for the vSphere administrator to focus on. The next area then are these services. Now, again, I'm simplifying this into two services. There are a number of others, but these are the major ones. There is the cluster IP service, which allows communication internally within the Kubernetes cluster between entities inside the Kubernetes cluster. The cluster IP service is not accessible to the outside world. Now, that has a lot of uses for sure, but it's not much point in having an application, perhaps if it can't be accessed eventually by the outside world. So how do we do that? We do a service type of load balancer, which provides access to the applications from outside the Kubernetes cluster. So cluster IP can be thought of as an internal service for communication. Load balancer can be thought of as an external service. There are others, but these are the major ones. And the interesting point here, again, for vSphere administrators is that there is no internal Kubernetes load balancer service. It has to be provided by some entity outside of Kubernetes. So again, this is the second area where vSphere administrators can begin to engage with Kubernetes, because the perception is that you as the vSphere administrator will be responsible for providing this load balancing infrastructure outside of Kubernetes. So storage and load balancer services are the two areas I'm going to focus on here to allow vSphere administrators to engage with Kubernetes, get up to speed in Kubernetes. Now, there's one part of all of this that I haven't, and I won't be going into in detail because we only have 30 minutes, but this is all of the networking that goes around service communicating to pods, pods communicating to the outside world through the host, through the virtual machine on which it's running. All of that is taken care of by a component called a Container Network Interface, or CNI. But we're not going to get into that here. The CNI is something that is installed in the Kubernetes cluster in the same way as the CSI is something that's installed in the Kubernetes cluster to allow all of that networking to take place. But for the purposes of this presentation, we're just going to focus on the CSI driver for doing persistent storage on vSphere volumes, and also the load balancer service and how we can provide a load balancer service to the Kubernetes clusters that are running on top of vSphere. Great, so here's our Kubernetes cluster. The application is running there as well. And just to reiterate on the fact that the load balancer type services has to come from outside the cluster, has to be provided externally, and persistent storage has to be provided externally as well. So if this Kubernetes cluster is running on top of vSphere infrastructure, guess who's responsible for providing these two services? This is provided by the cloud provider. In this case, it's vSphere, and it's our vSphere administrator who's responsible for managing all of that. So again, vSphere administrator, Kubernetes clusters running as virtual machines on top of vSphere. These Kubernetes clusters want load balancer services. They want persistent storage. This is where you have input. This is where you get engaged. Okay, cool. So the load balancers, what do you need to know about them? So being VMware, well, kind of getting ahead of myself, I guess. Yeah, what do you need to know about them? So when this Kubernetes cluster is running on top of vSphere and you have more than one control plane node, well, in that case, you're going to put a load balancer virtual IP sitting in front of this control plane. What that means is that you have your DevOps personas accessing your Kubernetes cluster through a single virtual IP. They're not connecting directly to a single control plane node. And the advantage of doing that is that if there is a failure, it is seamless to the DevOps persona. In other words, they don't have to do anything at the client side to continuously be connected to the API server. As I said, the connections just are routed in a round-robin fashion. If control plane 2 is down, they'll just be routed between control plane 1 and control plane node 3. It's completely oblivious to this DevOps persona that there has been a failure. From a connection perspective, they can continue communicating and talking to the Kubernetes API server even when there is a failure. So this is one of the first reasons for having a load balancer virtual IP range available to Kubernetes. The second is from an application perspective. Again, you will have a load balancer service that's sitting in front of a bunch of replicated pods that are all providing the application service to you. And if one of these pods goes down, again, doesn't really matter because the application users who are using the application have a load balancer virtual IP that they connect to that will just round robin between the remaining pods, providing continuous access to the application without them having to do anything at the client side. So these are why we have a load balancer type service in Kubernetes. It's all about availability. It's all about continuous access to the application, to the API server. Losing components that make up the application because they're all replicated means that there's no interruption to service. So now, being VMware, we don't just offer one load balancer. In fact, we have 3, but it all depends on the type of Kubernetes that you are using. So if you're using vSphere with Tanzu, also known as TKGS, short for TKG service, we do offer a HA proxy. Now there's a sort of concern or a consideration to bear in mind when you're using the HA proxy in that support does not come from VMware. I mean, we'll obviously support the configuration and setup, but if there's something intrinsically goes wrong with the HA proxy itself, it is a third-party product, so you have to go to the HA proxy directly to see what the problem is. So for that reason, I guess, it's great for proof of concepts. It may be good for production as well. The choice really is yours, and whether you want to use a third party for support or whether you want a full stack VMware support. If it's the latter, if you want VMware to support the full stack, then the load balancer of choice would be the NSX Advanced Load Balancer, NSX ALB, which is the Avi Vantage product. We purchased the Avi a number of years back, I think, and so with it came this Vantage load balancer. So this works both on vSphere with Tanzu, the TKGS flavor. It also works with the standalone TKGs as well, if you're familiar with that. Yeah, obviously a lot more bells and whistles in this one, a lot more things to be configured, a lot more options and so on. One thing to bear in mind is that there are different editions. So there may be features in the fully fledged edition that are not in the lesser editions. And just to bear in mind that the edition that comes with vSphere with Tanzu is a reduced feature edition, so you may not get all of the fully fledged features that you would see in the enterprise edition of NSX ALB. So just bear that in mind as well. Last but not least, there's a load balancer also in NSX that you could leverage. So if you're an NSX customer, it's already deployed on your infrastructure, you're looking to deploy Kubernetes, any of the TKGs, you can absolutely integrate with NSX as well. The one thing to bear in mind is that the current flavor of load balancer in NSX is going away and it will at some point be replaced by the NSX Advanced Load Balancer. So again, it's just something to bear in mind. It's fully supported today. You don't have to use the NSX ALB with NSX today. But if you look at the release notes, there is mention of the fact that there is a plan to eventually remove or I suppose, how's the wording? I don't recall the wording exactly, but it's just that there won't be any new features added to the current load balancer in NSX. The plan going forward will be integrated with the NSX Advanced Load Balancer. Great. Okay. That then brings us to storage. So I mentioned this already. When there is a request to persist data within an application running in Kubernetes, how we do that is we build persistent volumes. Those persistent volumes are actually instantiated as VMDKs, virtual machine disks, on vSphere data stores or vSphere storage. So two different types of volumes that you come across. Well, there's a couple of others, but these are the main ones. Once again, there are read-write once volumes and there are read-write many volumes. So these are the two different persistent volumes that you're going to come across predominantly in Kubernetes. The read-write once is a persistent volume that is dedicated to a pod. So all of the containers within the pod can access it, but it can't be accessed by containers in pods external to that particular pod, if you get what I mean. So it can't be shared. That's, I suppose, the easiest way to say that. It can't be shared between pods, as opposed to read-write many, which can be shared between pods. Now, when you're deploying dynamic persistent volumes, these are persistent volumes that are created as you request them. That's what we mean by dynamic. Read-write once volumes are block on vSphere storages. So they're block volumes. When it comes to read-write many, they're file shares. Read-write once block volumes can be provisioned on any vSphere data store, VMFS, NFS, vVols, vSAN, the whole shooting match. You can do that. When it comes to dynamically creating read-write many persistent volumes, the only supported infrastructure is vSAN file service. vSAN file service is the only infrastructure that we have that will provision a file share and then make that file share available as a read-write many persistent volume to Kubernetes pods. Okay. So just to keep it in mind, I mean, there are use cases for both. Predominantly, we see read-write once, but there are certain applications that look for read-write many. Again, this is dynamically created ones. There's nothing to stop you from building an NFS file share and then statically making that available to pods within Kubernetes, but the overhead involved in that it can be quite painful. Really what you want is a dynamic method of doing that, and vSAN file services allows you to do that just by creating the YAML manifest and making the request for a read-write many volume, and then it all gets created on the fly as you need it. Okay, so those are the two different volumes. So what's going on under the covers to allow us to do this? So we're coming back now to the CSI driver that I mentioned previously. Now CSI, Container Storage Interface, there's lots of these drivers out there. All of the different storage vendors will have their own flavor of CSI as well. But there is a vSphere CSI, which creates persistent volumes as VMDKs on top of VMware storages. And that's what we're using in this particular case. So we have our, we begin with this concept of a storage class. So a storage class is a Kubernetes construct to define, well, as the name suggests, a class of storage. But what we put into our storage class when we're using the vSphere CSI driver is a storage policy. And that storage policy allows us to select lots of different types of VMware vSphere storages, data stores. In other words, so we could have a storage class that picks VMFS, we could have a storage class that picks a particular type of vSAN volume, we could have another storage class for another type of vSAN volume, we could have a storage class that selects vVols. All of these are defined in the storage class construct within Kubernetes. And as I said, the storage class points to a different storage policy. So once the storage class is created, we can go and create what's known as a persistent volume claim, which actually goes out and builds up a persistent volume. So that's what the developer would do here. They would build a YAML manifest for a storage class, YAML, yet another markup language. And then once the storage class is created, he would build a persistent volume claim that references a storage class, which in turn references a storage policy. So you could provision a persistent volume on any of the different VMware vSphere storages, data stores. Great. So uses kubectl, sends that manifest off to the API server saying, build me a volume. And what that does is Kubernetes sees that there's a request for a persistent volume. It sees it's associated with a particular storage class. In the storage class as well, there's a reference to the CSI driver, it sees that it's a vSphere CSI driver, and then knows to redirect it to the appropriate CSI component running in Kubernetes. So that will go to the vSphere CSI component in Kubernetes. That has been designed to communicate back to vSphere to a component on vCenter called the CNS, and the CNS will then go through the process of provisioning the virtual machine disk. It's a very special virtual machine disk. It's a first class disk, FCD. It just means that we can do operations on these first class disks without going through the virtual machine construct. Cast your mind back, if you do a snapshot on a virtual machine, if you want to do a snapshot on a disk, typically you would snapshot the whole of the virtual machine. By essence of it being a first class disk, we can actually do the snapshot operation on the VMDK and other operations as well, but snapshot is the one that springs to mind. So anyway, we now have created this virtual machine disk. This virtual machine disk now gets attached to a worker node. Your kubelet there sees the attach coming in, it does the formatting, and the pod container that's going to consume this this persistent volume is instantiated, and the kubelet just mounts the volume into the pod. So that's in a nutshell how it all ties together. Again, keeping things very high level, very simplistic, but you can see hopefully now how a vSphere administrator would absolutely have to be working hand in hand with the developer to figure out the different storages, storage classes, what policies should be created, because there could be different requirements around storage depending on the application. You may want very high level, very fast, but very expensive storage for certain applications, so you might want to keep a limit on that. But then there might be another requirements for some, cheap and cheerful, really scale out blob type storage that we're going to be, throwing backups onto or something like that. Then you might come up with another policy that would point to maybe the low cost data stores in your infrastructure, and then working hand in hand with the developer to figure all of that out. So hopefully that's given you a good idea now about how all of this ties together, how it's important for the storage to, for the vSphere administrator to understand that storage plays a big role in Kubernetes and how they can work with the developer, with the DevOps, with the Kubernetes cluster admin to control all of that. So great. Okay. Now, by essence of the fact that we have the CSI driver sending lots of information back to vCenter, to the CNS, by that I mean we're capturing an awful lot of the metadata that's associated with persistent volumes. We're able to display all of that metadata in the vSphere client. So you can see a screenshot I've added here, lots of persistent volumes being created, lots of different Kubernetes clusters. Perhaps they're on different data stores, perhaps they're using different policies. You can see the compliance state, you can see the health state. All of that is here. So now if you get a query from the Kubernetes cluster administrator, and they may have some issue with a particular persistent volume, you can very quickly home in on the Kubernetes persistent volume to VMDK mapping, first class disk mapping through this view here. So you can very quickly home in on what device they're talking about, what disk they're talking about. Is it a performance issue on that disk? You can check what policy they're using. Perhaps it's gone out of compliance. Maybe there's been a component failure. All of that is visible through a single pane of glass here, which makes conversations between Kubernetes cluster administrators and vSphere administrators much easier. So I think this is a really decent feature of the vSphere CSI driver, to be honest. So last but not least, once you are providing persistent storage to your Kubernetes applications, you're going to be on the hook for being able to do backups and restores of those applications as well. Now, these are subtly different to virtual machine-based applications, as you can imagine, and already a lot of our partners will have Kubernetes plugins to allow you to do that. But if they don't, and you're looking for a solution to do backup and restores of Kubernetes-based applications or containerized applications, along with the persistent volumes that go with that, VMware has a product called Velero, which will allow you to do that. It's an open source product. You can see the website there, velero.io, but it does allow you to do backups of Kubernetes-based applications. One thing to bear in mind is that it does require an S3 object store or bucket to send the backup data to. There's lots of solutions out there that will allow you to do that. So we have a number of partners that provide S3 object stores. So yeah, it's just one such solution. As I said, if you already have a backup partner, they more than likely will have a Kubernetes solution, but it's very important to just highlight the fact that if you're providing persistent volumes for Kubernetes applications, think about the backup and restore of that as well. So yeah, Velero from a vSphere administrator's perspective, you can set up automated backups and schedules and all of that good stuff. But of course, it also provides on-the-fly backup capabilities for your developers if they wish to take a backup of an application before they modify and test something and so on. So yeah, just one such solution. So I'm going to just highlight again the areas I feel vSphere administrators should be focusing in order to get a foothold in the Kubernetes world. Like I said, there is no inbuilt load balancer mechanism within Kubernetes. The expectation is that it will be provided by the infrastructure. And so we have a number of load balancer solutions that I mentioned to you. And so definitely have a look at those and how services work and load balancer service and so on. The other side of the house then is storage, another big area that the vSphere administrator would be expected to help out on, providing feedback on, or perhaps even building storage policies to map the demands of the developers from a storage perspective. Do they want really fast, powerful storage, low latency, high throughput, or are they just looking for some kind of blob storage that they can throw stuff down on, and it could be cheap and cheerful scale out storage there. And of course, the backup thing I just mentioned, that's something else you'll have to bear in mind. Great. So that's it from me. I will just leave you with this plug for a book that I wrote last summer. It's Kubernetes for vSphere administrators. It goes through all of the stuff that we just talked about over the last 25, 30 minutes or so, but it has a lot more detail as well, and does focus on a lot of vSphere specific Kubernetes. So if you are looking at seeing Kubernetes coming into your environment, running on vSphere infrastructure, it might be useful. Feel free to check it out. So I'll leave you with that, and I think now we're going to just handle any Q&A that we may have available. Thanks again for watching.